Hello everyone, in this video we are going to see binary tree's largest subtree sum. This is one of the most frequently asked interview question, and here we are given one binary tree. We have to find which subtree has having the largest sum. In this case, you are given binary tree which having a positive numbers, so the whole tree is the answer. Summing up the whole tree nodes is the answer. And here is the node definition as data. It will have right and left pointer. But when this question is asked, some of the numbers you'll get it as negative numbers. Here are some of the nodes will have negative numbers. You have to find out which subtree gives me the largest number in the given tree. Here is my code snippet and how I'm going to approach this problem, and it gives me the answer. It expects two parameters, one is node and one more is sum, and in the sum variable will only carries the data, so data answer. So we have to update this sum in the code body. Okay, here at the first line, if the node is null and I don't have any job to do with that node, so I'll just return it. I have to deeply go to the left side and right side, and I have to find out the maximum of when I'm having the sum and when I have the subtree data. It's added, and I have to find out which is the maximum out of this and update it to the sum, and return that L and R plus the data for this L and R data for the upper stack calls. So my answer will be in the sum variable. And in this case, when you're picking up a node, you have to take all of the nodes, all of the children nodes comes under this node. So if you're picking up 4, the 6, 4 are applicable under the summed up and are propagated to the upper levels of the nodes. So we'll see those things with an example. Here we've given one tree, and for this tree the answer is 70. You have to add these 3 nodes, and this is the largest sum you can get out of this tree. So you have to print this value as 70. If you add this 40 and 50 gives me 90, and subtract the 20 from there, it gives me 70. So we apply this algorithm, and we'll see how to solve the problem. First, at initial level, I am passing this node 10 to my program, and sum as negative infinity. In computers, negative infinity is not there, so what I'm doing is I'm giving the int 32 min. So I'm giving int 32 min, so this which gives me the negative infinity, like that kind of an answer. So I'll pass that, and first thing, it will goes to the first line. It checks for null. It is not, so it will go inside, and here you have this left node, so it deeply goes inside. So here also it goes inside, and first time it checks this max, so max sum and LR data, so nothing is there. So what it does is it initializes that returned. I may get a confusion that if I'm returning the negative infinity, what it happens when it is 0, what happens. But in the best case, you have to just handle those cases separately. But in this problem, there is one node, at least one node will have positive data, so that the thing is applicable. Here you can think of it and returning negative infinity, but when I'm adding this numbers 40, and both are negative infinity, so 2 times of negative infinity and plus this data, that gives me the wrong answer, that case also. So both of the direction you have to think. So in this case, it's better for when approaching this kind of problem, you can return it as 0. That's the best thing, that because you're taking this sum and you're adding here. Okay, this 40 ultimately, what in this problem we are returning it as a 0. so that the addition of L and R not give me a wrong answer. So what I'm doing is I have to add 0 plus, here also it's returning 0, so 2 zeros plus this 40, so it propagates me 40. And similarly this 50 at the time I'm going to the right side of this node gives me 50. So what it happens is here 50 and 40, and it will add this 20. That's for L plus R plus data when this node is considered. So 90 plus so 70 will be updated in the max and some variables. And the similar things here, it minus 60 it returns, and here 20, uh, and here when it this case here it seems it is minus 40, and plus 10 is minus 30, and here also it is 30, here 7 is here minus 30, here 70, and here 10. So when this one is added it gives me 50. So out of this I have 70. Okay, but in this problem I'm again saying there will be at least one positive node, because when it is a negative nodes everything is there, that time it is different, so it's better to return here 0 only, return 0 when it is null. Okay, we'll see in the one more case. Here what the answer is, we have to sum up the whole tree, which gives me the answer as 110. You cannot take a subset of node, it is a largest subtree. So if you're taking this one, this will be 90, and if you're picking up this whole tree, then the answer is we have to subtract that down 40, and it gives me the answer as 110. And in this tree these all three nodes are negative, and you pick up this node, if I'm selecting only 70 it is just smaller value, but if picking this node 50 it gives me 130 minus 50, it gives me the answer as 80. Okay, now we'll implement this code snippet in Visual Studio Code and checks for whether the answer is right or not. Okay, I'm switch back to Visual Studio Code. Here I have necessary import statements, and I have declared the node class, and it have some data left right parameters, and the constructor is there. And the below lines in int main body, we have the same tree definitions in a coded format, and we're supposed to get this answer as 70, 110, and 80 respectively when we execute this code. So we directly write the program. Okay, I'm returning int and sum, subtree sum. It expects the root node, so node star root, and next parameter I need a sum, so I'm getting it as int sum. And inside of the function I have to check first if root is nothing is there, I just return it. I have to go to the left tree and right tree, so subtree sum, have to nodes roots node left, and same sum, and same thing for right also, and it returns me some values, so I'm updating it as int L, and same thing for int R, and how to find maximum of these two, so sum equals to max of sum comma L plus R plus this data root dot data. Okay, now what I have to return is return left and right and roots data, because when we are taking we have to take that whole subtree into the account, so I have to take in that one. And here in the main function body I need a variable, so int p, like I can declare it as sum, and I'm assigning it as int 32 min. This is for just a summation purpose, and here inside of this n subtree sum, and they have to pass that node n, and sum as this sum, and here I'll just write the sum. Same thing I have to write for other programs also, so I'm just copying, and here you have to send node m, and here also node m, and here it is y, and here also y. Okay, our program is ready to run, so run the program. You get the 70, 110 and 80 as the answer, as we seen in this iterative approach. So 70, 80, 110 and 80 is coming. So all of our test cases are passing, but you have to consider the preconditions of this things. So when you're considering, you have to what you're returning, and what's the tree, how it goes, and how do you find this maximum. This matters in this program. So hope you understood this problem and solution, and thank you for watching this video. We'll meet in the next video.